Welcome to the Cribble Enriching Data video. In this video, we will show the power of using Cribble to take regular old logs and turn them into rich contextual events. Logs often do not contain the information required for an analyst to easily group and look across dimensions to recognize patterns or drive troubleshooting. In this instance, I have a normal weblog I would like to be able to slice and dice by customer demographic information like location, age, and gender. First, we will show how to use Cribble to take a normal Apache combined weblog and parse it into a structured event. Once structured, we will extract a session ID from the query string and use that session ID to look up the username from a Redis server. Using the username, we will make a REST API query to retrieve information about the customer. Finally, now that we have a rich contextual event, we will output that event to a system for analysis, in this case, Honeycomb. The demo environment that I'm using for this video can easily be run on your laptop. Check out this repo on GitHub to easily follow along with what we're doing in the video. Now that I have my demo environment up and running, I'm going to create a new pipeline. This pipeline is initially empty. I'm going to start a capture via the Cribble UI. Captures reach inside the running data flow to grab events so that we can work with them interactively in the UI. In our case, I want to just grab everything flowing through right now, which in our demo is only one data source. In production, you'd want to set this to a much finer grained filter. Now that I have a sample I can work with, notice that I have some structure in this event. The file it was read from, the source type of the data. But inside _raw, there's a ton of other information. In order to use this well in my destination system, I want to parse and lift the structure out of the weblog entry into the event itself. For that, I'm going to use a parser function, which ships with support for Apache combined weblog format. I add the parser function, and I add one additional field to the field list because my log also contains a time taken field. Now, as I hit save, I can see that there's a lot more information in my event. I have the request method, URI, bytes transmitted, time taken, and other information. Next, I see there's a session ID in the query string, but I'd like to have that in its own field so that I can use that to query Redis to get the username. I add a second parser function to this pipeline, and I use the key equal value parser to get the fields out of the query string into their own fields in the event. Now that I have a session ID split out, I want to look up in Redis the user associated with that session. This really shows the power of ingestion time enrichment, because if I was to do this join operation at query time, we would have to maintain a list of session to username mappings for essentially all time, which would be a massive lookup table. Doing an ingestion time allows me to run the lookup very close to the time of data generation, and bake in the mapping as the data is moving. I've added Redis lookup function to the pipeline and configured it to talk to my Redis server. After hitting save, I can now see that I have a username coming back from Redis. Next, I want to go from that username to more information about this particular customer. Using the username, I can make a REST API query and retrieve more details about the customer. I'm adding a REST lookup function, which uses the username in the event to pass through to the URL. Once I hit save, now I can see that I'm getting back a large amount of customer information from the REST API query. As I'm doing my analysis, this will allow me to examine my weblog data by location and other demographic information. Now that we have a rich contextual event, let's output it to Honeycomb. One of my users is complaining about slow response times, so let's see if we can use our new context to help narrow down the problem. In order to output to Honeycomb, we configure a Honeycomb destination, inputting the dataset and team ID for authentication. We also use a conditioning pipeline, which I'm not showing here, but is available in the demo environment, to flatten the data structure, putting all the customer fields in the main object and removing the raw field. After letting the data accumulate a bit in Honeycomb, I'm going to start my investigation. I add a heat map and a 95th percentile of time taken to start to understand if we're seeing high response times. We can see from the heat map that we have a few outliers in terms of performance, but they don't seem to be really impacting our 95th percentile latency. Clicking bubble up and highlighting the outliers, we can see that there's a few things in common amongst the outliers, including the city and state. Adding those to our breakdown, we can see that it seems primarily a few users in South Lake Tahoe are being impacted. Maybe there's some bad weather up there. In conclusion, we can use Cribble to take ugly old logs and turn them into rich, wide, structured events. The additional context in our data can make it possible to look across dimensions to find commonality that simply was not possible using the log alone. If this is interesting to you, we'd love to hear from you. Send us an email to hello@cribble.io or grab the bits at cribble.io/download.